Hello, Mike Kako Kumui here. We're going to build on the concepts from part 2 in this part. This is part 3 of linear equations and their graphs. We know how to write the equation lines, and we're going to just add some complexity by talking about parallel and perpendicularity. Okay, so before we begin, a quick joke. What did one pencil say to the other pencil? You're looking sharp. All right, here we go. Let's jump into this. So, we know how to write equations of lines using not only point-slope form, but slope-intercept form. And we're going to take that to the next level. So they're asking us for point-slope form for the line that's parallel. The thing you have to understand with parallel is that the slopes are, well, let's talk about what parallel lines are first. These are parallel lines. Notice that their slope, their pitch, their slant is the same, and that is the key to understanding how to write the equations of these lines. So, what if our problem was this? This is a brand new problem. How do we write the equation in point-slope form for a line that's parallel to this, but it has to go through this, okay? Because this point doesn't lie on this line. If we plugged in a 2 for x, we would get 1/2 of 2. 1/2 times 2, that's 1. 1 minus 4 is -3. This point is off of this line. It's not on this line. Okay. So how do we write the equation of line that's parallel to this that goes through that? Well, remember, you need two things when writing the equation line. You need a slope. We know the slope. It's got to be half. We know, and then we need a point. We know the point. It's 2, 3. They're asking for point-slope form, so let's just keep practicing point-slope form. Y minus 3. Remember, your eyes got to search for here that y value. 1/2 x minus 2. Okay, let's expand this. Or convert it to point-slope form. 1/2 x minus 1. And then we're going to add 3 to both sides, so we have y equals 1/2 x plus 2. Okay, let me show you this should be consistent if we took this and wrote it in, tried to write the equation line using slope-intercept form. So slope-intercept form looks like this, you recall. Y equals mx plus b. That's our mold. First thing you do is throw in the slope. Then stop and realize all we need is a b. How are we going to get the b? Well, we got to put in all values for all the other variables. So y, it's 3. 1/2 times 2 plus b. 3 equals 1 plus b. Solve for b. B happens to be 2. Where does it go? Don't go all the way to the top line. Go right here, because that's the word you're missing. So the final equation is 1/2 x plus 2. Notice how beautifully consistent. Okay. Now for perpendicularity, perpendicularity is a major story. Okay, and for perpendicularity, do I want to talk about it here? Maybe I'll talk about it later. But to get into this idea. Perpendicular, yeah, I think I do need a little picture for you guys. Negative 3x plus 1. Negative 3x plus 1 should look a little something like this. Y-intercept of 1, and it's got a slope of -3. So what does that entail? Make sure it's pitching this way. You go down 3. 1, 2, 3, and across 1. Bang. Okay. Or you go up 3, 1, 2, 3, and across 1. Okay. Now here's the key. To have a slope, this is the theory. To have a slope that's perpendicular, it needs to come across like that. It's got to create a 30-degree angle. I'm sorry, did I say 30? It's got to create a 90-degree angle. Okay, and notice this line over here, this dotted blue line, that's pretty darn flat. Its slope should be close to 0 because the slope of a horizontal line is 0. So what is the slope of this dotted line in order for it to be perpendicular to the green line? Well, you simply see it probably goes through this point here and this point here. What is that? That's a rise of, first of all, it's a positive slope line. If this is negative, this has to be positive. They've got to be opposite signs, okay? If you're trying to draw perpendicular lines, one's positive, the other's got to be negative, okay? Or if one's negative, the other's got to be positive. That's always the case. So the slope of this blue line down here is positive, rise of 1, run of 3. Notice something? 1/3. There is a relationship between our target line, which we're trying to write the equation of, that's perpendicular to this, and the slope of this line. The slope of this line is -3. What's the relationship? These two slopes, in order to create perpendicular lines, need to be opposite, meaning positive, negative. If this is negative, this has to be positive. They need to be opposite reciprocals of one another. Okay? Sometimes you hear the term negative reciprocals. I don't think Mr. Mike uses that term, or Kumu Wen. I have seen books like that, though. I don't like that term. It should be opposite, meaning if one's negative, the other's positive. And when one's positive, the perpendicular slope line has to be negative. Okay, that's what we mean by opposite. A reciprocal, you just take the fraction and flip it. So, in order for it to be perpendicular to this, we need a slope of positive 1/3, and it needs to go through 5, 1. And we just apply our point slope formula. Y minus 1 equals 1/3 x minus 5. And since they don't want it in point slope form, they don't want it in slope intercept form, you just leave it and call it a day. Okay, bing bang boom, and Bob's your uncle, your pal. Okay, this is really similar. Tell whether the lines are parallel, perpendicular, or neither. At least we have some groundwork. If I graph this first line, half x plus 3, 1, 2, 3, rise of 1. Rise of 1, run of 2. Okay, or I go down 1 and left 2. Either way, we've got a line that looks a little something like this. And if you graph this other line, you don't have to graph it, but I'm showing you. It's got a slope of -1/2. Ooh, cool! Look at that awesome relationship. They must be perpendicular. The one's positive, one's negative. Careful, careful. For it to be perpendicular, there are two conditions. It needs to be opposite reciprocals. Are these flips of each other reciprocals in terms of the fraction? No, they are not. And let me prove that to you graphically. Okay, to graph a line with a slope of -2, you can think of this as -1/2 or 1/2. If you think that way. Either way, though, you've got to make sure your line decreases from left to right. So you go down 1. I'm looking at this first. Slope, rise of -1, run of 2. Or if you look at this, it's a rise of +1 and a run of -2. These lines are not perpendicular. Okay, they are not. No way that's a 90-degree angle. If you need to tilt your head and look at the screen, go for it. It's not perpendicular. So those are neither. If you look at this, this problem that I've created, these slopes are opposite reciprocals. And yep, I was talking about slopes of -3 and 1/3 up here, right up there. So we won't need to graph that. Actually, I saved myself some time. Those are clearly perpendicular. Okay. Next skill, changing an equation into standard form using integers. Standard form, remember, standard form is basically ax plus by equals c. A, B, C can be positive or negative. Kumu Wen, Kumu Mike. I know Kumu Mike likes to emphasize that he loves to have the A positive. That's just a preference, okay? Standard form, nowhere does it say in standard form that the A has to be positive. The A can be positive or negative. The B can be positive or negative. The C can be positive or negative. It just doesn't matter. Just make sure that the X's and Y's are on the same side of the equation. If we're putting it in standard form, though, we need integers. Oops. Integers are whole numbers and their opposites. Whole numbers, that's 0, 1, 2, 3. Whole, how do I remember that? That looks like a whole. And they're opposites, so we got -1, -2, -3, ... going this way, and ... going that way. We need whole numbers and their opposites. So we start out, we got to get rid of that fraction, multiply everything by 2. So we got 2y plus 4 equals, this 2 will cancel with that 2. We do not need to distribute it because you only multiply by 2 once. You don't multiply this left side. You don't multiply this right side by 2 twice. You just need to do it once. So x plus 4. Okay, you move the x to the left. So we can have -x. That's totally fine. Plus 2y equals, you subtract 4 from both sides, and you actually get that. Write a 0. If it's 0, it's 0. Okay? That looks a little odd. You might want to double check that. How would we double check that? Well, let's just try to put this in slope-intercept form just for kicks. Remember, the original equation looked like this. 2x plus 4. Before we multiplied it by 2. So let's distribute. That's a half x plus 2. You subtract 2's from both sides. That goes bye-bye. That goes bye-bye. You have... Let's move the y over to the right, shall we? You subtract y from both sides. And you get 0 equals 1 half. 0 equals 1 half x minus y. Let's multiply everything by 2 just for kicks. Okay, I'm going to move over here. 0 times 2 is still 0. Then you have x minus 2y. Aha! This looks a little different from this, but no, they are equivalent. How do we know they're equivalent? Okay, if I wrote this underneath here, I would have x minus 2y equals 0. These two equations are equivalent because, okay, there's a couple ways we know this. Let's say we isolated y here. Okay, we'd have negative 2y equals negative x, and we would get y equals 1 half x. We already know this. Oh, no, we don't. We didn't do it. So if we were to isolate y here, we would get 2y equals positive x, and divide by 2, you would get y equals 1 half x. These are equivalent. You get y equals 1 half x either way. The other way you know that they're equivalent, guys, is if you just simply multiply this equation by negative 1 on the left and on the right. It doesn't do anything to the right because 0 times anything is 0. But if you multiply this left side by negative 1, you will get positive x minus 2y, which is what you see right there. Positive x minus 2y. Okay, they are equivalent. They come from the same equation. Okay, so that's how to convert to standard form. Hope that's a good review. And let's do a little word problem, and that's the end of this section. Let's say I have $200 in my account and I withdraw $30 a week. Write an equation relating the amount in the bank to the number of weeks. All right, so the amount in the bank, well, I have 200 to start with, and I'm constantly deduct 30 per week, where x is the number of weeks. It looks a little something like that. So this is a major skill in math of modeling, and this makes sense. If my x is 1, I'm going to have $170. If my x is 2, I take out two sets of 30, so I have 20 minus 60, 140. Okay? So good luck on that. If you have questions, guys, always let me know. Maha.